Okay, so we are going to start. Today we are going to have two talks. Uh, our guys from Israel is going to talk about are going to talk about legacy projects, legacy code, and how to deal with this stuff. How to maybe refactor it, how to completely rewrite, and so on. So the first speaker is Dalia Simons, our server architect. Please welcome.
Project if you ever get the task. Oh, that was surprising. Okay. So, how are legacy projects born? So no project is born as a legacy project. You never see someone wake up and say, I know I'm going to write a legacy project. So all projects start with an idea, and it has to be a good idea. So a product manager or someone else in the company has an idea for an exciting new feature, exciting new component server, and then developers gather and they work, they design the architect, they write a lot of code, and we have a shiny new project. So it's in production and it's successful. If it's not successful, it's not going to be a legacy project. So it's successful and it gains customers, and over time we add more and more features to it. But after a while, we kind of leave it and it becomes a legacy project. And the question is, why do we leave this project? If we had a project and it was so successful and we added a lot of features, why is it suddenly a legacy project? And so there are a few different options. The first one is that there was just a shift in the technology. So, for example, at Wix we started. Huh? What happened? My IntelliJ died. Okay, we're back in. Okay, we'll survive. Okay, so at Wix, when Wix was first founded, it was founded as a company for creating Flash websites. So our main project was Flash. So we had this wonderful Flash editor, and people could just go and create their own Flash websites. And then suddenly something happened because those things were invented, or not exactly this one, the iPhones, and they don't support Flash. And so we had a problem because we have this great tool, and Wix was known as Flash. If you said Wix, everybody would say Flash. And then we had this great tool, but it wasn't good enough for the market anymore. So it didn't matter how our code was written, it mattered that this was just not good enough for us. And so what happened was that we had to rewrite the whole thing in HTML. So now we have an HTML editor for creating HTML websites. So our old Flash project has become a legacy project, and it's too big. It became a legacy project, and we have to support it. So we still have customers. We still, up to this day, still have customers that they have a Flash website. I'm just sorry, it's just too big. Okay, that's better. You can hear me? Yeah? So...
Is it working?
Excellent. So we still have customers up to this day that are using our old Flash editor, and it is a legacy project that we keep maintaining all the time, but we have moved to the new project, so no new features are added to this project. It's a legacy project. So the second option is just projects that are badly written, which is most of the legacy code that we know and we run into. So you have code that isn't tested enough, that wasn't refactored, the code becomes very complicated, and then we get this great spaghetti code, and we get to a point where we can't add any more features. So we had such a project. In fact, it's the project I just showed you before. So when we moved from Flash to HTML, we did it very, very fast because the market was running away and we had to get a new product out there. We didn't want Wix to be associated with Flash only anymore because the market was moving to HTML5. And so we wrote it very fast. And then over time, as we added more and more components, and there are a lot of different components on our editor, then it just became too hard to add a component. We got to a phase where in order to add a new component, they needed 4 months, 5 months of work. And so they decided to just stop all work on this old editor and rewrite it again. This time, they wrote it with React. So it was an opportunity to move to a different technology. But the reason they moved was not because of the technology. The reason they moved was because the code was just not written well enough, and they couldn't add any new features to it. It was becoming a liability. So they rewrote the whole thing just for the sake of the development process being much faster. And then the third option, which I'm not going to go very deep into because Doron is going to talk about it in his lecture, is when you actually have a really successful project and you have so many new customers that you see that your current architecture isn't good enough for a load, for the stability. So there are too many, it's a success, but there are too many people that are using this system, and it becomes very hard to work with it, and you need a complete new architecture to work with it. And the example we have is the example Doron is going to present to you in the next lecture, which is our Wix stores. That was originally written on Magento, but after it grew, they have rewritten it in-house, and Doron will talk all about it. So then, if we have any one of those use cases where we decide to rewrite or deprecate, and now we have a legacy project. And those legacy projects are kept alive because we still have customers who pay good money, and we have to keep giving them service. Now, the question you probably ask yourself is, if we rewrote the service, why didn't we migrate the users? Why are we still with this legacy project? If we rewrote it, and it's new and it's shiny, why aren't we moving the users? And the answer is that usually we really like to move our users and just completely delete the old code. But a lot of times the migration is just too hard. So it will take a lot of resources. If the database is completely different, then it can take a few months to work on such a migration. And sometimes it's just not worthwhile the money that it's going to cost the company. So at the end of the day, it's a management decision if we're going to spend the time working on the migration of users from the old project to the new one or not. So we always strive to migrate, but it's not always possible. Sometimes we just decide there are more urgent things that we want our programmers to work on, and then we are just left with those legacy projects. So what can we do? We got this great project. What can we do now to maintain it, to run it? So the first thing we would all like to do, everybody, is rewrite the project. So I'm going to rewrite this project with the newest technology, with my favorite language. This time I'm going to write it properly. It's going to be TDD. Everything is going to be perfect. So that's in our fantasy world. In the real world, a lot of times the company doesn't have the money, the time to let you sit for a few months and rewrite this project nicely. And so sometimes we do. Sometimes we take old projects and we rewrite them. But most of the times, it's just not practical. So the second thing we would like to do is just go into the nastier parts of the code and refactor them. So I would say I would sit now for 2 or 3 weeks on this project and refactor so it would look a bit better. But the problem with that is that most of the projects that we inherit, all those legacy projects, are not tested properly. And it's very hard when you're a refactor to know if you damaged anything. So it's very risky to refactor a project that you are not the one who wrote it and doesn't have proper testing. So you don't trust what you do when you refactor. And so the third option is the option I'm going to talk about today, which is making small maintenance tasks over time. And I'll go into more details. But before I do that, I want to explain why I think the option of doing nothing is a very, very bad option. So we all know and like to say that if it's not broken, don't fix it. But I think it's very bad. Because if you do nothing, your project starts rotting. And the reason it starts rotting is that the project is not isolated. Okay, so a project lives in an environment. So it interacts with other APIs. And so you might find that some other projects change their API, even an external project. You connect to Google and suddenly they're deprecating the API you need. And if you're not maintaining it over time, then making small changes like that become a huge task because suddenly your project isn't compiling and you have to go and see, and it's very hard. So there are a lot of different use cases like that. So for example, we have third-party libraries in our code. So sometimes we are not going to update those for a long time, and suddenly there's an urgent security fix. So now I have to go and update this dependency, but I find myself jumping from version 1.2 to version 5.3, and God knows what happened in all those versions on the way, and so it's very hard. And then sometimes you might actually find an urgent bug in your code that needs fixing. So that's pretty rare. I can say on my projects I had, I think, 2 of those over the years, but it does happen that suddenly the security team finds an urgent bug or something that people didn't realize, and you have to go and fix it. You don't have a choice. And the last thing is that external technologies we work with, so for example, the database, the queues, those versions might be upgraded, and you have to go and upgrade your driver because it's not, your project can't keep running on its own environment. It always interacts with the other technologies we work with. So that's why I think maintenance, small maintenance, is the balance between constantly paying off the costly technical debt, and the other option is your project decaying over time. So what are we going to do? So before we start, you have to own your code. So each project has to have an owner. So there's no such thing as a project that a few people, there's a team, they're in charge of it, maybe they look at it if something will happen. So each project has to have one designated person. So at Wix we have one owner. It's actually written on the project who's the owner. And then usually, I think in a lot of companies, you would give those legacy projects to juniors. They just joined in because no one wants to maintain them. But we actually believe that the more senior developers should be maintaining them because they're older codes, so the people that are more time in the company actually understand what's going on. And also, they do it, it's not our main project. Okay, I have a main project I'm working on, but I'm maintaining this project as a side project, and it's a big responsibility, so we actually give it to the more senior developers. And the second thing before we start is remember that Rome wasn't built in a day. So when you get a project, any new project, it's very hard. It takes time to start understanding what's going on. When you get a legacy project, it takes even more time, especially since there are no tests to guide you, and you have to start looking, and you don't know what's still relevant and what's old code. So it just takes time. You have to be patient when you start working on a new project. So now we get to what I call my 4 rules to staying alive. So number 1 is keep everything under CI. So at Wix, we work with continuous integration, which means every time we push a code into the code base, our automatic build is run. And it also means that every new feature we push, we immediately put onto production, deploy to production. So we always want to make sure that our project has the latest version in production. So we make sure the build is always green. So if someone else made a change that broke my project, I immediately go and fix it. I don't wait. Okay, if someone broke my project, I go to him, I say, hello, you broke my project. And I asked him, what did you do? And did you have to do it? And if he had to do it, and a lot of times people will just tell me, oh, just go and delete this code, or just go and change this line. So I just go and do it. And the other option is because it's my project, I'm the owner, but I think it's a shared responsibility because it's an old project. So if it's something a bit bigger, I ask the person who broke it to fix it. And sometimes, or most times, they actually go and do it because they broke it and they're now working on the feature. They understand the whole concept that they're doing, and it's easy for them to just go and fix this one feature. So they go and do it. And the second thing is that we deploy to production regularly. So we actually have an automatic email that is sent once a month and says, you haven't deployed your project for a month. You have to deploy it. And the reason we deploy it is because when we deploy, even though our code didn't change, the dependencies have changed because other dependencies have released new versions. And so once a month we deploy, and I know that the code in production right now is maximum 1 month old. So I never get a really old version in production that is not working anymore. I did deploy a new one and I don't know what to do because I always, once a month I deploy, and sometimes there are problems. Sometimes I'll deploy and I'll see an exception because someone changed something. Suddenly there's a class cast exception or all kind of runtime exceptions that I didn't see before. But it's much easier for me to find who broke me if I deploy once a month. So I deploy once a month, I see a bug, now I know there's 1 month to look back and see who did what, but I don't need to look for 6 months or a year back. I always know it's 1 month, and I can fix the problems if they happen. So the second thing is keep up to date with dependencies. So at Wix, we usually do it automatically. That's why we build. So we get automatic dependencies, and they get updated. But if not, you should really go and update the dependencies every time they have a new version released. I think this is also a good lesson for newer projects, which we tend to choose one version and just stay with it. Because otherwise what happens is that suddenly there's an urgent security update and we have a really big jump to do. And usually what happens is over time, every release, they deprecate something else, and then eventually they delete it. And then if you updated it and it was deprecated, then you can see it and you get a warning that something is deprecated, and then you know what you need to do. If they deleted it, then you need to start digging and understand what's going on. So I wrote here, as long as it doesn't break compatibility, but I actually update, usually, even if it breaks compatibility, I just go and make the fixes. So it can take me an hour or two usually to find what's changed and just go and make the fixes and update my dependencies. So before I talk about the third point, I want to talk a bit about our framework. So at Wix, we have a framework, like most companies, where we have a lot of shared services that everybody uses, like all the network calls or security services. And so this framework, we keep adding more and more code to it. But we found out that over time, we made a lot of changes to it, and then suddenly we had pieces of code there that only legacy projects were using. So we had code that only the Flash editor was using and a few other projects that are related to him. But no one else was supposed to use them, except that we found out that people are using them because they found it there and they used it. Because they found a class and it looked interesting, so they decided to use it. And so what we did was we isolated that code. So we took it out into a new project. We called it Wix Legacy Don't Touch. And then, and then we moved all the legacy projects to depend on that project. So all the legacy projects, it was an easy job. We just moved them. We just changed, added a dependency for them for the new project, and they are now dependent on it. But what it let us do is delete a huge part of code from our framework that we didn't want other people to use. And we went to all the projects that were using it and said, hey, you're not supposed to use this. Go use the newer library, such and such. So my third point is quarantine your dead code. So don't pollute other projects. Don't leave your old code that is not supposed to be there in your project. And code that exists will always, always be used. And the fourth step is that just that making small steps are the key. So it's always very frustrating if I now have to work for 2 weeks on the project. Okay? That's the absolute worst case. I cannot work on this project for 2 weeks. I go crazy. So I prefer to do small steps over time. So I remove deprecations. So I like to invest about 2 to 3 hours per month on this project. And then what I do is I go over everything that is deprecated and I remove it or change it. And then if I have time and there's no deprecations, I improve tests. So I go and add a few more tests where I know they're needed. And then I make small refactors on the tests I already wrote the previous month. And I remove dead code. So removing dead code is something we tend to ignore, but is important. So a lot of times we wrote a new controller and we left the old one because there was a transition mode. And then once we moved to the new one, we just left the old code there. And we have all kinds of APIs that aren't used anymore. And the next person is going to touch this project, it will be much nicer for him if he can only have code that is real and won't have to deal with code that is dead and no one calls anymore. The most important thing is that always keep the campground cleaner than you found it. So if you went to a piece of code and it took you a whole day to understand what on earth is going on in this code, don't leave it like that. Okay? Refactor it. Sometimes it's very small refactor that can make more sense to other people. So like extract methods and give them a name that someone can actually understand what's going on. And it's small steps. So extracting methods, shouldn't take you too much time. But once you understood a nasty piece of code, don't leave it like that. So go and fix it. So till when? How long am I going to continue maintaining this HTML mobile project? I keep asking it all the time, and the question is forever. The answer is forever, but that's not the real answer. So the answer is those projects are making money. They're actually making the company a lot of money because they spend $0. They don't spend $0 because they spend 2 or 3 hours of my time every month, but it's close to zero for them on development. But they get a lot of money. Our customers are paying every month for those projects that are almost no work on them. So they will run until the technology will die. So in the case of Flash, I think within a few years, Flash will just die because most browsers today don't even run Flash automatically. You have to run it. And I think we'll just see the browsers stop supporting Flash and it will just die. So the technology will just die. And the second option is when you migrate. So some of our legacy projects are on the way to die because we're very busy doing the migration. Like we're migrating the old Wix stores to the new Wix stores and the old HTML to the new HTML. And it takes time. It's a very long project. And there are a lot of little dependencies. But eventually, once everybody will be migrated, they will die. And the third option is when they're no longer profitable. So I think over time, we'll probably see the number of our customers going down eventually, maybe, I don't know. And then if the company decides this project is not profitable anymore, then they're willing to give up whatever number of customers that are still left, and they will kill it. So I think the things to remember is that a little maintenance that you do regularly will keep your project healthy and up to date, and it will make it much easier when you have to do a big fix on the project to actually go and do it. And I think it can change a bit the way you look at legacy projects because although I don't like maintaining legacy projects, like if you would ask me, do you want to come work in a company to maintain our legacy projects, I will say no. But I think the fact that I do it over time and I maintain these projects actually gives me a lot of credit in the company for stepping up and being willing to do things that other people are not willing to do. And it's actually not such a hard task for me because I put all those stages into place. And so I think it can be a big success for you. You can turn it around. You can take a very boring task and turn it around and say, this is going to be a successful project I got because they asked me to do it, and I now only spend 2 to 3 hours, and it's a big success. So it can really turn it around. But that's it. Any questions? Oh, yes.
Wait,
So you've said that you have to assign one person on the piece of code. And what happens if that person leaves or becomes sick or something?
Okay, so it's a very good question, because if we have only one person that knows this code, what happens if he's away on vacation for 2 weeks now and there's no one to maintain it? So it's a problem. It's a problem. But on the other hand, if we'll have 2 people in charge, so nobody will be in charge, because people tend to ignore those. So they say, oh, he's also in charge. So I think what happens in the company, like in our company, what happens usually is that there are a few other people that actually know those projects, because they were written not that far ago, like 5 years, 6 years, and we still have people that are working. So we still have a few other people, but it's a very good point. It's a very good point. I think maybe there should be one owner and one assistant owner. That will just to know the code and know a bit what's going on. I think maybe the other thing to think about is that we really try to make all our projects look the same, or at least similar. So we use the same technology, and it has to have the same structure, sort of. And so it's easy for people to go into a project they don't know and look around. Usually, if there's an urgent thing, it will be very specific. If something now happened that has to, it will be very specific. So it will be maybe someone else will spend a bit more time to understand what's going on, but it won't take him forever to do it. So yeah. Okay.
You said, hello. You've said that each piece of your code, each piece of code inside the project should be used, and there are no dead code inside project. But I know that any project has libraries, and inside library we have a code which never uses inside our project. So my question is, where is the baseline where we decide that this code is our code and it must be used, and this code is third-party libraries code, and this code can be inside the project infrastructure and shouldn't be used and may not be used. Thank you.
Yeah, so I don't consider third-party libraries as my code. I consider them as code I use. So I don't take responsibility for them. I didn't try them. They're not mine. It's a cheat? Maybe, but it's not. When I want to keep my project, I want to keep it small. I'm talking about my code. So when I want to remove dead code, what I usually do is I go and I look in the tools we use. So we use New Relic and Anodot, and I see what flows are still getting traffic, because flows that didn't get any traffic in the last month are probably dead. And then I start from the controller level. I say, there's a controller here that doesn't get any traffic, so we can remove it. Let's check what it's calling. Is someone else calling that? No one is calling that? Okay, let's remove that as well. So I usually check like a month back, and I assume that if a month back no one called this API, then no one is using this API. Now, it did happen to me once that I removed code and someone needed it. But I deployed it, and then a day, 2 days later, someone wrote to me and said, I was calling this API and now I get an error, and then I just reverted. So it's very easy in Git to just revert. So, but I've done it a lot of times, and I only had one complaint, so I think it's okay.
I have a question. So speaking about the third-party libraries, have you ever had a problem where the other developers just broke completely rewrote the library that you are using completely in a non-compatible way, so that well, what do you do in those cases? Do you try to upgrade? When do you stop upgrading if you are actually see that you can't upgrade easily in a short amount of time and so on?
Yeah. So I think what usually happens, like in libraries that are internal, like are written in weeks, I think we go and upgrade because if someone changed, we need it. With external libraries, I think when they make a really big change that is breakable, then usually what happens is if they have security fixes, they do it for the older version as well. So usually when you see a major version, like they went from version 2 to version 3, and they completely broke the code, so they know a lot of people are still working with version 2. And so if there will be an urgent security fix, they will make it for the older version as well. So in that case, I would say, yeah, just stay with the highest version you're still, because if it's, completely rewriting, like I would say, if you look at it and it's more than a day's work, then probably not worthwhile spending your time on it.
Thank you. That was me.
Dalia, thank you for interesting speech. And I want to ask you such situation. Imagine such a situation that our technology is is becoming outdated, and we need to upgrade it all the time. But it causes a new cost, additional costs, and the rate of profitability of our project becomes lower. So what will you suggest to do to leave it alone and with existing profitability, or to upgrade it even if we will have the same profitability at last?
So I think if you have a project that is decaying and becoming, and it's your main project or it's one of your big projects, and at the end of the day, if you can't add features to it and it's your main project, you have to rewrite it. You don't really have an option. You have to rewrite it. You have to update it. And it's worthwhile the cost because then you can add new features to it, or you might get it more profitable in the future. So I guess it depends on the specific use case. But I think usually, and we do it a lot at Wix, we take a project that became very hard and we go and rewrite it. But you have to know that it's gonna, it has a cost. Like we're rewriting now one of our big projects, and we say it's going to take us 2 years and we need 2 programmers. And the management said, okay, so you have 2 years, here's 2 programmers for 2 years. But not all companies. I think small startups can't afford to. So it really depends on the situation. If it's your main project and it's running, your technology is outdated, then you don't really have a choice. You have to go forward. Otherwise, you'll just find yourself stuck, and over time, you'll start degrading. That's my 2 cents. Yeah, maybe if you have an idea for a new project, that's always great. But yeah.
So you just talked about production projects, and what about internal projects? So when we should decide rewrite it or keep supporting?
Yeah. So I think internal projects are a bit of a sore spot. So in Wix and I guess in other companies, a lot of times you find internal projects actually being getting less attention because they're not production facing. So production will get the first attention, and then we'll see that internal projects aren't getting the same attention. I think it's a mistake. So I'm actually driving a project now, one of our old internal projects that we want to rewrite as well, because there's a reason we have internal projects. They're usually to help our developers or help our marketing or help the company work better. And if we're not giving the same attention to internal projects as we give to external ones, to production projects, then we're actually harming ourselves. Because if our internal projects will be better, we'll do our job better. So I think we have to give. It's hard, but we have to give the same time. Same effort for internal projects as external projects.
Hello, thank you for your speech. It was really interesting. Can you share some experience about moving one complicated legacy project to a few microservices or to a group of microservices?
That's a big big topic for my next talk, but I'll just say two words. Right now I'm working on a project that is a big legacy project, and we are dividing it into 7 different microservices. And the way we're doing it is we have a general idea. So we made a general architecture, like we could identify different components, so we identified 7 different ones. And then we identified the main flows. So we don't know all the flows because I checked and there are 144 API calls on this project. So I don't know all the flows. I don't understand how they managed to get so many APIs. And I don't know the project at all. I'm working on it. I don't know it. I just joined. So, but what I did was I sat with people that know a bit, and I mapped all the main flows. And now we're starting to move flow by flow. So we'll do the first one, and we'll move our production to use the first flow on the new code. And then we'll do the next one. And then gradually we'll move everybody. So I say it's a 2-year project. We'll gradually move all the flows we know about, and then we'll check what's left behind.
Okay, thank you.
Another question? Okay, thank you, Dalia.
You're welcome.
5-minute break.
You're welcome.
Say something. AA. 1, 2. Can you hear me? Yeah?
Maybe a little bit closer.
It can be closer. Like that?
Say something again.
Can you hear me? Can you hear me? Yes?
One more time.
Can you hear me? Yes.
Yeah, we can.
Now I can talk.
Ребят, рассаживаемся, пожалуйста.
Writing.
Okay, we're going to start. The second talk will be about migrating our old system into the new shiny microservices and how the people at our e-commerce team use CQRS and something, and even sourcing for actually migrating all this stuff. Doron will tell us about that. Please welcome.
Hey, can you hear me? Yeah? Hi everyone, I'm Doron. I'm working in Wix for the past 7 years today, actually. I've been part of the team that written both the old e-commerce solution and the new Wix store. And that's not working. So that I already spoke what Wix is doing. Just a couple of more words. Wix is changed its purpose in the past few years. Now it's a place that is supposed to manage your business. If it's a restaurant, a store, an hotel, whatever, it's like one-stop shop to manage your entire business. We are going to talk about the stores, particularly, where we give you the possibility to manage your catalog, your orders, your inventory, and everything else. So basically, all your web store is managed via Wix. Also, the PayPal configuration, the shipping, the tax, and that's it. So we used to have an old e-commerce solution based on Magento, that is an open source code written in PHP. And today I'm going to talk about how we change it to the new solution using 3 design patterns, and why exactly we did it. So about 5 years ago, the management came to us and asked us to build an e-commerce solution. We didn't have anything back then, and they want something that to go to the market as fast as we can, with something working like MVP. So we picked up Magento, went to an outsourced company, and built Wix, let's call it Wix modify Magento library, and we went out to the market in just 3 months. So we got a monolithic server written in PHP over Magento. It took us 3 months, and it worked for about 2 years. We needed to do, someone knows Magento here? Yeah? So Magento is an open source for running stores. Some of the biggest stores in the web running over Magento. It's supposed to be written for big stores, single tenant on each Magento service, and that each store should have like 100,000 of products. And what we did, because what we needed is, instead of single tenant solution, we needed a multi-tenant solution. So we changed Magento a bit to support millions of stores that each one of them have 10 or 100 products. So it worked for 2 years. After 2 years, because we diverted from the Magento path, because we written our own solution, we couldn't even upgrade to the next Magento version. We couldn't use the community of Magento because each plugin they wrote didn't fit our needs because it was for a single tenant and we were multi-tenant. We had monolith server that I think everyone here knows the pain points in monolith server, and I'm going to talk about how we broke it. It was written in PHP, and it's important to say that in Wix we have we call it server guild, about 100 developers, and in that time all of them wrote in Java or already converted to Scala, and we were the only team that wrote something in PHP. So each time there was a new feature in our framework, we needed to port it to PHP, and we couldn't use anything of the framework Wix gives us. We couldn't even get other developers to come and help us because we worked in a different language, in a different environment. And the ugly. So after 2 years, we saw the average response time from our servers got to about 300 milliseconds. That's high. And because we did a very quick ramp up of the project, I'm writing it as stop provisioning took 2 seconds. Provisioning in Wix means that you drag a component into the stage. Now you need to provision it to tell the service that's running it you have a new instance of the service and you need to do something on your side. We did it quite naively, and we just copied all the data from the original store. And then we came up, in the end we had like 80% of garbage in the database that we don't know what is garbage and what is not. We started to be very afraid to deploy the code because we hired some junior developers that started writing really spaghetti and ugly code, and we wasn't aware of it till it was too late. And we had no dev velocity, like imagine that your product comes to you and asks you how much it will take to do this feature, and you say how urgent it is, or are you sure there's nothing more important we need to do before this, and stuff like that. And what was the red flag is that we couldn't scale. We do in weeks once in a year, like projects overview, where some architects and other stakeholders review all the solutions and what the people did in the past year. And then we saw that we can't scale for 2 times the traffic or 2 times the data. So that was the red flag. So then we faced the dilemma. What should we do? The management came to us after we told them that we are going to eat the wall. We don't know when it will be, but we are going to eat it. And they say, okay, so you're smart people, go and give us what do you think we should do? So we went to a room for about 3 weeks. We were 6 people back then. And we have the 2 options, if you want to refactor it or we want to rewrite it from scratch. Basically, that's the actual result we gave to our management. We said that if we were going to refactor the code, we still will continue to deliver. We'll only refactor the critical places in the code that needs to be refactored. But we'll still be stuck with that technology, because if you're saying you're going to refactor and you say, I'm going to replace all the persistence layer in Magento, the only thing that Magento gives you is a database, then you're going to rewrite everything. And we will still be in different stack than Wix. If we rewrite, if it's done correctly, of course it will solve all the old system problems. But also we'll get as Dalia mentioned before, we'll be aligned with the Wix guild conventions, and then we can get other developers to help us if needed. Also help us in production if something happened during night. And back then we were 3 developers, and if 2 of us were on vacation, the 3rd one needs to be with computer on him all the time, because no one understands other than him what's going on. And now everyone understands. Product freeze for 6 months. This is what we thought it will take us. It might fail. Like you start to rewrite when you don't know what you're going to do, and then you find yourself writing code for 2 years and chasing your own tail. So we came to a conclusion that we came to the management and told them that we want to rewrite everything, even though that the users really liked the old solution, but we saw that in the future it will block us, because we are actually, Wix is a big company. We have now 1,200 employees, but we are against Shopify and Etsy and companies at the same size. And in these companies, all the employees working on e-commerce solution. In Wix, now we are 50, but back then we was 10. But we thought that we need to build a good skeleton and that will help us to gain much more fast the velocity. So this is what we did. So a couple of signs you need to start think if you need to do something is when you move too slow. If you start to tell your product manager that the feature is too complicated, because you're not the one that's supposed to say that, and if you're afraid to touch the code or deploy the production. So basically what happened is that we said to the management, okay, we want to rewrite the code, but they said, okay, start. So we asked, what's the product? Where is the UX? What are we going to write? And they told us, just do feature parity with the old product, and when you get there, we'll tell you what we want for the future. So we asked what was going to be the feature plans of the product, and they also didn't knew. So basically, we knew that we were going to write a lot of code, and we don't know where exactly are we going to do, where are we going. And we knew that in the old code, in Magento, we only used like 40% of functionality. So we took a decision that the only thing we are going to do is writing an infrastructure, both in the client and both in the server, that is flexible enough to add new feature fast. Like we said that it will take us 6 months, it took us 10 months, but we built something that is more flexible, and it was the first project in Wix. I'm not going to talk too much about it, but it was the first project in Wix that was written in full TDD from the beginning, and we deployed to production after 2 days, something hello world, like that. And since then we continued, and we decided to also implement in the team like working methodologies and stuff like that. And now I'm going to talk about 3 design patterns that it's our own flavor of them. It's not like how they're written in the books. We discovered that what's written in the books is not suited for us, so we changed them a bit. The first one is there's a monolith server that was the beginning, the old solution. There's a monolith server that's talking to a database. And in Wix, because at that time we already have all the infrastructure for microservices to deploy them, to run them in CI, to roll back, and to test their interaction, it was very easy. So we just moved to this architecture. We changed it a bit because in our solution we have a lot of services, like internal services, we call them. For example, orders, catalog, now I have a blackout, order catalog, checkout, cart. Each component can stand for himself, like a real microservice. Each one of them has its own database that it is the only one that can access to. Between them, they are talking in JSON RPC, and that's written in Wix framework. And they have the renderer API that it's also some microservices that give you, for example, the SEO renderer or the web renderer, and the API level that is REST API or GraphQL API. And they expose our structure to the outside world. We decided to do it like that because inside our cluster it's very easy and we can break anything. We don't promise compatibility, and we have like the signed contract to the outside world. So now we have decoupled architecture. We can deploy it independently. No more deploying your friend's code without knowing exactly what it's going to do. Actually, each one of the services, we have about 12 microservices now. Each one of them deploys a couple of times a day. And we are going to a phase that we want each push to go to production and roll back if needed. Also, right now they are written in Scala. We are going to change maybe one of the renderers to be written in Node. So we are not longer coupled to any language or technology. We can change anything as long as it can expose JSON RPC. So we don't have a single point of failure anymore. We don't have unrelated feature dependency. We learned that you need a serious infrastructure to manage all these microservices, but as I mentioned, it was a no-brainer because we already have it in Wix. What we discovered when we started working like that is that we have a new challenge that's called backward and forward compatibility. I'll explain it really quick. Let's say we have 2 services that talks with them with the DTO called product, and you want to change the product. Everyone do it all the time. So you'll expose a new service A that can handle both a product and product tag, and then you'll expose service B that can handle only product tag, and then you've finished and you can continue rolling forward. What happened here is that we created the coupling between both services, and now we need to think which one we should deploy before the other. And we don't like it because the only stuff that you want, or the only thing you want to think about deploying to production is if the build is green, I can push and the next version can go up. If I start thinking when I have 12 microservices on about 50 machines and a lot of instances, and I'll start to think which version is up in production, and most of the time I have 2 versions because it's not all the services moving instantly to the new version, and it will start to get ugly, and I need to think, and I don't want to think. So basically, it's going to be like this on production. So there's a lot of way to solve it. You will just upload and you'll show a new API, and then deprecated API, V1, V2, V3, and after a while you start moving them. We decided to take it a bit different. Our next design pattern is exactly that. There's a traditional CRUD. Let's take, for example, when the client wants to send update product to the server, it will just send the new product with the change the price, for example. We change it, and we are now using event sourcing. As I mentioned, our own event sourcing. From now on, the client won't tell the server what to do. It will tell him what he wants, like what happened. He will send a command. Instead of just pushing a new product and tell him, save it, because I need it later, he will send a command. The user want to change the product price. And we'll save it in the server as in past tense that it's already been done. And now we'll see what changed in the get. In the traditional CRUD, you'll get, the client will ask for the product and get the product from the server. And now in the event source solution, we have a view, that's the terminology, a view of a product. Imagine that in the database, I'm saving all the events from the beginning of history, and it's immutable, and I never delete any event. So the database will look like product created, product price changed, product added a picture or something like that. And then if the client wants it, I just take all the relevant events from the database, aggregate it, and return the view to the client. So what it actually gives us is that I don't have anymore any DTO in the system written anywhere. It's not persistence anywhere. It's only in the code level. So if the client wants a product for a list view, or product for SEO, each one of them is like a projection of the events in the database, and I can build them very quickly. I don't need to change the database for adding new views. Adding commands is also very simple. The client can add new command. I'll save the event, and once the client tells me that he can get the new views, I can just start sending them. And this is how the system looks now. The client sends a lot of commands, and we are returning the views. This is the Magento old relational database. After working on it 2 years, I still don't know 50% of it. And this is how our current database looks like. You can see that we have like store ID, We have the version, so we can take the events and sort them by order. It's a timestamp. And we have subject. Subject is like product ID or category ID or order ID or any other thing. And we have the type, so we can deserialize the JSON. So what we solved here, it's the backward and forward compatibility became much easier to solve. Of course, it's still there, but we don't need to think it as before. And we have a much faster velocity because we don't need to migrate. I'm sure all of you migrated data in databases and schema changes and stuff like that. So we don't need to do it anymore. What we learned is that we started only with the catalog as a POC because it was new technology in Wix. It took a long time to convince the entire team, including me, that this is the correct way to go. Eventually, now it's after 2 years that we've written the new system, we refactored the entire services, and all of them except one is working as event sourced. And we see that it's much easier to work like that. And another problem is that the code is more complex, and it's a different paradigm. So you need to invest in a good framework. And at that time, when we started writing, there wasn't a good framework. Actually, we are going to open source our own library very soon. So we did most of the work for you. So we got another challenge now. After we came up with this solution, we started seeing that, well, I have tons of events. I'm saving everything that the client did, even if I don't need it. Like, let's take for an example, rename product, rename product, rename product, rename product, rename product 10 times. The only relevant one is the last one, but I'm saving 10. And take that to a store with 1,000 products. You can get million events. And I don't want to delete anything because this is also available for me as an audit log. And now I can also fix bugs and see how the user got to this state. And it's really helping. So I don't want to delete all the events. So we saw that above like 1,000 or 10,000 events, we see a degrading performance because we need to fetch everything from the database and play the events in memory. And that's not cool. So this is what I showed before. The client asked for a view, and the server returned it. And then if another client comes and asks for the same view, I'm returning it again. And then what the pattern says that you already calculated the view. Why do you need to calculate it again? You can persist it in another database, and then you already have the aggregated events. So that's what we did. We created another database called the snapshot database. And now what we do is when the client asks for a view, we first check in the snapshots database if we have an updated version. If we have an updated version, we just return it to the client. If not, we get the delta events from the events database and just play them. We are not playing everything from the beginning of time. And if this database that is actually like JSON bulb, like we have products and collections and orders and everything. Everything is like built big JSONs, and that's it. And we need to change the view name. We can just delete this database and rebuild it for free. It will cost in performance, but we can do it. It's like it's a self-healing database. So this is the code. It's in scallop pseudocode. There's laser. Yes. So you can see that we are doing get snapshots with ID. We're checking if the view is the latest version. And if it is, we just return the snapshot. If it's not, we are just apply the new events from the events repo. We are updating, saving the snapshots, and then returning the new snapshot. It's very simple, and we found it very helpful in aspect of performance. So now we have decoupled, basically, we have two SLAs in Wix. We have the editor. The editor is where the merchant is working on his store, like adding new products and stuff like that. And the editor needs to be fully consistent, because if I'm adding a new product or changing the price and I do refresh, I want to see the same stuff I saw before, or the browser crash, or anything else, or if we're working simultaneously on two browsers. But my viewer must be eventually consistent, which means that if you get data that is half a second old or a second old, it's not that important, or the SEO or anything other than that. And this is from New Relic. This is the point here. We open the snapshots database, the feature toggle. We can see that the response time got from about 80 to about 40. This is 2 years ago. And this is this week. And now we have like 5 or 6 times the traffic. And now we're standing on 18 milliseconds, because we improved the scheme and we learn how to work with it. And that's a response time for a database with 300 million rows, MySQL, with about 10K requests per minute. And what we learned here, that snapshot is really cool because you can just delete it and deprecate it, and the system just will rewrite the new views. It's again a little bit more complicated, but that's what you get. Let's make it a long story short. One example is the free shipping coupon. That in the old solution, the product came to me, and I'm always laughing with him on that. That he asked me how much it will take, and I started to think that I changed the shipping rule table, I changed the coupon table, I changed how I calculate the cart from these tables. So I can't just take a free shipping module for Magento and plug it in. And I told him that I need to write it myself, and it will take me 2-3 weeks. And do we have to do it? And in the new solution, it actually, true story, it took us a day since we decided to do it to deploy it to production, and it was working. Now, 2 years after, we are not developing as fast as that. But we still didn't do any big migration or needed to change the design like totally. And so that's it about that. So to wrap it up, when do you need to stop and think? When you move too slow, when you tell the product manager to give up, when you're too afraid to touch the code and deploy to production. And this is some extra reading of the by-the-book design of this design patterns I talked about. And that's it.
Any questions? Okay, I'll ask first then. Well, I know that you have a problem that you will not actually solve, and you can't actually solve in that. And the problem is that you, having the fact that your viewer is not fully consistent, you can't guarantee that there is, for for example, if there is one product left and two buyers just bought the product, they will both actually complete the checkout successfully. How are you actually going to solve this problem from the business side of it?
We have a disclaimer that states that says that it's one of the biggest problems in the e-commerce world, and those companies that are working only on inventory management. How we solve it is we say to our users, most of them is like small businesses, so they will prefer sell inventory that they don't have than not selling. So we have a disclaimer that you can sell up to -1 inventory. And but it never happened to us in the past 2 years since this product is online. So it's a problem for Amazon, like in the same millisecond in the database. Because if you try to insert an event and you are not have the updated version, you get exception from the database. So we say with Tatiana, the DBA, when we'll have this problem, we'll be very happy. We need to solve this problem.
So how does event sourcing solve the problem of service dependency? So if my service is an older version and it does not know what an event means, then how would it handle it, the event?
An old service know what event means?
Well, yeah, so you have service A that serves an updated version of some JSON object to service B. That's a problem. So what if instead of that, with event sourcing, service A pushes an event that is a new kind of event, and service B wants to consume that event, but does not know what the kind of event is, or if it's not even a problem, I don't know.
It is a problem, but basically the events is not, it's only a case class that's written in one place. You don't, there's one place that defines what an event is, and when you deploy it, it's like single point that goes to the entire system. It's not like a product change. You add a new event, eventually it will get to the entire system. It's not, you're not changing the protocol between services. Actually, what's going on the wire is strings, in our case. So, and what else? Microphone.
Thank you for the interesting information. May I ask deeper about 3 design patterns you mentioned? The first was about microservices, and
Wait.
wow. What's the logic? What's your approach? How to choose the list of microservices? How you picked one, or
basically, it's supposed to be different logic unit because each one of them have a different database. So what we did in e-commerce, it's rather easy. You have great. You have orders, you have products. So you separate the logic unit. A friend of mine from another company came and asked me the same question, and there's no like rule of thumb. If you see that now, if you have monolith server, so all the data in the same database, if you see part that can be decoupled and is not related to the rest, it might be a different logic unit. I'll start there.
So in e-commerce, it is standardized by other companies, for example, orders, users, and so on. What if it is a new field? It's completely new and no really good practices. What is your approach?
I don't have a good rule of thumb, but from my experience, we did it in a couple of projects, and it's really like pop out after that, and I don't have a good rule, other than that if there's separate of concerns between these two parts. Each product will start as a monolith server. Like our chief architect always say, you know that you're going to throw away your code in 2 years. So we start simple, and then you know better what's going to do. Don't start in the first iteration. Don't start with microservices because you don't know the domain yet.
Okay. So your answer is to see how things are going and pick up huge pieces and make them microservices.
Not exactly huge
not
pieces. Logic units.
Logical
not,
pieces.
Not small or big.
Okay, thank you. The second design pattern was about event sourcing. Yeah, as I understand, the idea is to make it more flexible by changing not the entity but collecting all events, and then when user would like to see anything related to this entity, show this entity and some events, last events that are available from our collected events. Yeah?
Yes.
So it is kind of splitting one entity into a few pieces. No,
yes,
what?
Yes.
Yeah.
You're piecing.
Slicing one huge.
It's not really slicing because now you think on a product, but eventually the behavior can come from a lot of places, and you need to stop if you want to change, to move to this design pattern. You need to stop thinking about DTOs and POJOs and all this stuff, or like relational databases. And the user did something, he wanted to do something, and then I'm just saving it. What I'm doing with it afterwards is something completely different. Like, for example, orders, I can get the events not from the client. I can get the events also from PayPal or from FedEx or from other places. And then PayPal don't need to know what FedEx did. FedEx don't need to do what PayPal did. And I'll get events from a lot of commands from a lot of places. I'm saving it and show the only the relevant data for each request.
Okay. Okay. Now it is clear. And the third one is about CQRS. Yeah. As I understand, the logic is to split one database into two databases. One is with snapshots, so like cache of that requests that were made before. Yeah.
CQRS. What it means by the book, that you have the writing head and the reading head, and you separate between both of them. So if I'm reading, I will read from one data source, and when I'm writing to a different data source, so if one of them fails, the other is still working. This is the by the book CQRS.
Oh, okay.
And we used event sourcing to get to it. A lot of people in the books are managing the saying CQRS is event sourcing or event sourcing is CQRS. They're not related, but usually people using both of them like we did. Using the snapshots as the read head.
So the idea is to split reading and
writing.
And write. Okay. Thank you. Really interesting approach. Thank you.
Thank you. In the end.
Bigo.
Hello. Thank you for speech. It was really interesting. I really liked your idea about splitting microservices. And I have a few questions regarding to it. Would you recommend to have the separate servers for each microservice? That's the first one. And another one, this approach needed for the huge projects, I believe. So you probably need somehow to scale it. How do you guys scale this architecture?
So the question about each service has different instances on different servers. That's what you asked. So in Wix we have a life cycle system that we can choose how many instances we want of the same service, and you know on which server you're going to be, and each server runs several applications. What we usually do is checking with our neighbors before deploying our application to this server. But what happens in the end that each server runs like 10 applications in Wix, and Wix says like, I think the current number is 500 microservices, and we have hundreds of servers. Each one of them have 10 or 15 instances of applications. So I don't say it's the best approach, because now in the past few weeks we see that we have hardware issues, and it takes a long time to figure that out, that it's not the code, that it's the hardware. But that's how we work at the moment.
And what about API render? Is it enough to have only one, or you should like
all of
balancer for that?
All of the services I saw have at least 5 instances on each data center, and we have 2 data centers. So we have 10 instances of all of them, and we can work master-master.
Okay, thank you.
Because of the immutability.
Have you ever had a chance to actually use event sourcing for querying the history data? Like, for example, how did the store looked like at some period of time, like
yes,
a year ago or so?
Yes, we do this just for debugging. We can limit the events with timestamp, and we get an older version. We do it only for debugging. We don't expose this to the user yet.
Plan to?
No.
Okay. Questions?
Thank you.
Thank you.